quadratic equations, and we're going to start with them in standard form. The standard form for a quadratic equation is the same standard form that we dealt with last Tuesday, and that's where you had ax squared plus bx plus c. And if we're going to be solving the equations and it's in standard form, we need it to be equal to 0. So that's how we're going to start with it. And notice that that's in descending order, just like it was when we were trying to factor on Tuesday. Nothing has changed about this side of it. We're just putting it equal to 0 today. So we're taking the extension of what we did on Tuesday and just making it an equation now. So we're going to get answers like x equals 5 and x equals 7, that sort of thing. Okay. To be a quadratic equation, the biggest thing is x squared is the largest exponent, or large. On the variable. That means, and kind of relating this back to what we talked about before, that means the degree is 2. Okay, so x squared is the largest exponent, got the largest piece in there. That's what makes it quadratic. If you had x cubed, it's not quadratic. X to the third power makes it a cubic equation, and we'll talk about that June the 27th. We'll talk about how to solve those. So what we're dealing with today are quadratic equations that have x squared. They have a degree of 2. What that degree tells us is how many answers we should have. Should get 2 answers on these. Some of them will have the same answer twice, but that's okay. It still counts twice. Okay, so every one of these is going to have 2 answers. So that's going to help us in we're doing our work here. You may have a repeated answer, but it's counted twice, and we'll talk about that as we get to it. So standard form, is where we're starting, and we're going to talk about the different ways to solve something that's in standard form, and then we'll kind of veer away from that and go to some other forms of quadratics and how to solve those. But standard form is how you're going to get them most of the time. So it's called standard because that's how it is most of the time when things are standard. So let's look at that and see if we can get going with that. So the first method we're going to use is the one that we learned on Tuesday, and that's factoring. So we're going to solve by factoring. Okay, so let's review quickly the factoring rules. The first thing we wanted is in descending order. And because we're solving, we want to put in there that we also have it equal to 0. If we don't have it equal to 0, we can't factor it yet. So we want to have it in descending order and also equal to 0. That's the only addition to the rules of factoring for solving that happens. And then, GCF is the first thing you look for. And then we count terms. If there's 4 terms, shouldn't be in this case. We'd use grouping if we're going to factor it. There are 3 terms. You use the X method. There are 2 terms. Since we're dealing with quadratics only, differences of squares would be the only way that we'd end up with that, because sums and difference of cubes are not quadratic, so that's not part of this particular section of stuff. But we know that that's going on. The thing with solving, when you get to the factoring, when you get all that done, to solve, you set each factor equal to 0 and solve. That's the solving part. Okay, and we're going to see that in some examples here really, really quickly. What that's called is, it's got a special name, and I'm supposed to tell you what it is. It doesn't matter that you know this name of that. It's called the zero product property is what that's called. And basically what the zero product property says is if you've got two things multiplied together and they equal zero, then one of them has to be zero, or it could be both of them that are zero. So the zero product property just means set the factors equal to zero, solve them. That's what we're using here to do that. So really, it's the factoring part is the same as what we've done. It's the solving that's added to it today. So the instructions are going to be solve, and we'll start with one that maybe it's x squared plus 2x minus 35 is equal to 0. So it's a quadratic, and we want to go through the steps of solving that by factoring. So first thing we want to check is it in descending order? And we have x squared, 2x, and a minus 35. So that's in descending order. And is it equal to 0? Well, yeah, right there, it's equal to 0. So it's already set up and ready to do the factoring with. So the next thing we want to do is solve it by factoring. It's got three terms over here on the side that's equal to 0. So we know we're using the x method to solve that. So what goes on the top of that x? Negative 35. 1 times negative 35 is negative 35. And 2 goes in the bottom. And we want it to multiply to be negative 35 and add to be 2. What does that? Good job. Positive 7, negative 5. Absolutely. Positive 7 times negative 5 is negative 35. 7 minus 5 would be 2. That's the right thing. Can I take a shortcut on my factors on this one? I think I can. And I would have x plus 7 for the positive 7 and x minus 5 for the negative 5. I can take that shortcut, remember, because there's a 1 in front of x squared. Anytime it's a 1 in front of x squared, I can use that shortcut to help me. Okay. Now, that's the factored form of that. The zero product property says to solve that, you're going to take each of these factors and set them equal to 0, just separately. So you're going to say x plus 7 equals 0, x minus 5 equals 0. So once you get it factored, you're to the easy part then. And now I just got to get x by itself on each of those problems. So I would subtract 7. Negative 7 is one answer. I'd add 5. Positive 5 is the other answer. Remember, the degree is 2. We should get 2 answers. So that's what we're finding here, is that there are 2 answers to that. And they're negative 7 and positive 5. There's the first example of solving by factoring. Scroll back up. Let's say we had something like this, maybe 3x squared minus 9x is equal to 0. So here we have, it's quadratic because the biggest thing in there is x squared. So that's not a problem. Is it in descending order? Yeah, we got x squared and then a plain x. Is it equal to 0? Yeah. So it's ready to factor then. So how would I factor this one? What's the first thing I should always look for when I'm factoring? A greatest common factor. 3x squared and 9, 3 and 9 have 3 in common, and they both have an x. So the GCF would be 3x. And then what would that leave in parentheses? Well, 3x times x gives me 3x squared. 3x times negative 3 would give me a minus 9x. So there would be the factored form. And I'm ready to solve it now. I've got the factor here, the 3x in the front is a factor, and then x minus 3 is a factor. So I say 3x equals 0, x minus 3 equals 0. So this first one, how do we get x by itself on the 3x equals 0? Divide, yeah, it's 3 times x. The opposite of that is divide, so x is equal to 0 divided by 3, which is always 0. So we get x equals 0 for that first one. The second one, add 3, get x equals 3. And because they're equations, guys, you can always plug in your answers into the original problem, make sure it works. If I plug 0 in, 3 times 0 squared is 0, minus 9 times 0, 0. 0 minus 0 is 0. If I plug in 3, I get 3 squared is 9, times 3 is 27, minus 9 times 3, which is 27. 27 minus 27 is 0. So I can always check my answers here because I'm dealing with equations. And that's always a good thing, is when you're dealing with equations, checking answers is always a nice thing. Let's try this one. X squared plus 12 is equal to negative 7x. What's wrong with this one? Not in descending order. It's not what? It's not equal to 0. So I think we can get it all in one swoop here, get it equal to 0 and get it in descending order, because what needs to move? Yeah, that minus 7x. And how do I move it over here to the other side? Good. I'm going to add it to both sides. Cancels out over there. There's my 0 that I needed. And now I just got to put it in the middle of the left side. And I've got it in descending order, and I've got it equal to 0, which is, the first thing we need to do. So I look for a GCF. There's not one. So there's 3 terms, though, so I'm going to do X method. Multiply to be 12 and add to be 7. Yeah, 3 and 4 would do that. Can I take a shortcut on my factors? Yeah, because it's got a 1 in front of x squared. So that lets me go straight to x plus 3 and x plus 4. Both pluses because it was positive 3 and positive 4 in our x. So they're both plus signs. That's that shortcut that we can take sometimes. And then we just set each of those equal to 0. X plus 3 equals 0. X plus 4 equals 0. Get x by itself. There's negative 3 and negative 4. 2 solutions. Degree was 2 to begin with. So that's what makes that happen. It's always nice. So getting a lot of practice on what we did Tuesday. So that's definitely a plus to what we're trying to do here. Let's try this one. 6x squared plus 7x equals 3. What should be our first step on this one? Yeah, getting the 3 in the right order. So how do we get that 3 over there to the other side? Yeah, subtract it. Cancels out. There's my 0 that I needed. And then let's put it in descending order. From there, it's factoring again. So we're trying to factor this. So I'm going to use that X method again. What goes on the top of the X this time, though? It'd be negative 18. 6 times negative 3. And then a 7 on the bottom. So multiply to be negative 18, add to be 7. Be 9 and negative 2, wouldn't it? Now, can I take a shortcut on my factors here? No, because that 6 in the front there says, okay, you can't take a shortcut. You got to do it the long way. So remember, the long way is taking 6x squared, and then you're replacing the 7x that's in the middle with these two pieces that you found in your x. So that'd be plus 9x minus 2x minus 3. Doesn't matter what order you put the 9x and the minus 2x in. If you put the minus 2x first, that's fine. You're going to end up with the same two factors. It just may look a little different as you're getting there. For if you put them in the different order. So I'm going to group first two together. Would be GCF of those two would be 3x, leaving 2x plus 3. And then what do the second two, what do I need to pull out of those? A negative, obviously, because of the minus sign that's right here. And then there's nothing in common between a 2 and a 3 except for 1. So it's a minus 1. And then that'll change the signs of both of those so that the parentheses match. Remember, that's a big deal when you're doing grouping. It's those parentheses need to match. So our factored form of this would be 2x plus 3 and 3x minus 1. And then we're just going to set each of those equal to 0. 2x plus 3 equals 0. 3x minus 1 equals 0. And a little bit more difficult to solve these two because you got something in front of x, but it's still 2 steps, and you're done. So nothing just incredibly crazy difficult about it. Subtract 3, 2x equals negative 3, and then divide by 2. Negative 3 over 2. So fraction answer. Fraction answer is absolutely okay with that. So it's not anything, abnormal to get a fraction answer. Usually, if there's a number in front of the x squared in the original problem, that usually means you're going to have a fraction as an answer. At least one of them be fractions. Solve the other one. Divide by 3, 1/3. Get our answers there. All right. So solving by factoring when it's trinomials, 3 terms to deal with. That's always a good thing out of that. Makes it work out real nice. But it's not always 3 terms. So I'm going to scroll back up and still see the end of that one. Sometimes you might have something like this. X squared minus 16 is equal to 0. So it's equal to 0. Great. Wonderful. But it's not 3 terms. It's 2 terms. So what are we trying to look for when it's that? If we're trying to factor. If we're trying to factor and it's two terms, and especially if it's got a minus sign in the middle, we're thinking, oh, that's a difference of squares. Hey, so I'm going to rewrite that as x squared minus what squared? What squared gets me 16? 4. So that means if I can rewrite it like that, then that means it's a difference of squares, and that means the factors work out real easy. You get x plus 4, x minus 4. I was going to shortcut to that. So if we can rewrite it that way, that's what's going to happen. That's always an easy thing to get. Now, from there, you just set each of those factors equal to 0. So x plus 4 equals 0. X minus 4 equals 0. And then solve each of them. So minus 4, minus 4. Add 4. And you get those two answers. Okay? So solving by factoring on a difference of squares can be done that way. In the next example, I'm going to show you a different way to solve one that looks like this that doesn't take factoring. It takes the square root stuff that we talked about Tuesday. Okay, and this is going to be helpful when going to start easing over into problems that won't factor, and we've got to learn how to solve those. So if you have the exact same problem, but for some reason you thought, I don't remember how to factor differences of squares, but I know I'm supposed to get x by itself. Well, I can get x squared by itself by just adding 16, right? And I get x squared is equal to 16. What's the opposite of squaring something? Taking the what? The inverse of squaring is taking the square root. So this is where the square root stuff comes back to us from Tuesday. Okay, so we could take the square root of both sides. The only thing we need to remember here, if we're going to do it that way, is that when we take the square root of 16, what two numbers could get us the square root of 16? 16 could come from positive 4 squared, but what's negative 4 squared? It's also 16. So when we take a square root to solve, we got to remember to do plus or minus in the front of it. Just a plus sign and a minus sign right on top of each other. So anytime you take a square root to solve an equation, you want to put plus or minus in front of it. Okay? And then you just work that out. You say, okay, well, what's the square root of 16? Well, I happen to know that when I memorized that the square root of 16 is 4. And then it's plus or minus. So what that does is it builds, two answers, positive 4 and negative 4. And that's the same two answers that we got over here by using factoring. But we did it with the square root. That's handy, especially when we're about to get to some problems where maybe the square root's not a good number. Maybe it's like x squared is equal to 18 or something like that. That's not a good square number. Square roots is a definitely good method for that. For a problem similar, like this one, where we've got, let's just do that one, x squared equals 18. So here we've got x squared by itself. There's no plain x in the problem, and it's equal to 18. So on this one, normally we would subtract 18, get it x squared minus 18. But we know 18 is not a square number. So we know it wouldn't even factor as a difference of squares because 18 is not a square number. So with that, when we see that anytime you can get x squared by itself like this, and it doesn't have a plain x in the problem, then square roots is the way you want to do that. Okay. As long as it doesn't have a plain x in the problem, square roots is a good method. Okay. So that's one thing you want to kind of keep in mind. So I would take the square root of both sides here to solve that. So I'd take the square root of x squared and then plus or minus the square root of 18. Well, 18 doesn't have a nice square root. So I'm going to do the stuff we did on Tuesday with the square roots. I'm going to break that down. 18 I know is 6 times 3, and 6 is 2 times 3. I've got a pair of 3's. So that means what comes out of the square root? 3. And then the 2 that doesn't have a buddy, that guy right there is the one that's left on the inside. So we get two answers, positive 3 square root of 2 and negative 3 square root of 2. We could get a decimal approximation for those if we needed it. That might be a good thing to go over there. 3 and then just second square, 3 and then second square root of 2, 4.24. If we go 2 decimal places, let's go 3 decimal places just to be a little bit more accurate there. 4.243. So approximately 4.243. Approximately negative 4.243. So you can get the decimal approximations. That'll come in handy when we start doing some graphing later on today. So we get those two answers there. That'll help you along the way is thinking about, I want the exact answer and a decimal approximation. That's always a good thing to have. The reason we want the exact answer, that's how your answers are mostly going to be on the exam. And then the decimal approximation is going to be helpful when we do the graphing. We talk about x-intercepts. That's always going to be a helpful thing. Let's do another example similar to that. Let's say we had something like 8x squared is equal to let's do 56. That's a good number. It goes into that. So this one is, it's the same kind of idea. You've got only an x squared in the problem. And so if it's only got x squared in it, then that would say, oh, do that by square roots. So let's get x squared by itself so that we can take the square root of both sides. So how do we get x squared by itself here? We got to get rid of that 8. How do we get rid of that 8? Yeah, just divide by it. Good, Mattis. So divide both sides by 8. 56 divided by 8, 7. And on this side, we got x squared left. Get rid of the squared. We take the square root of both sides. Plus or minus on the side that's got numbers. Always put that plus or minus. If you don't, you're going to miss one of the answers. 7, it's a prime number. It doesn't break down any. So we're left with plus or minus the square root of 7 as the answers. X equals positive 7 or positive square root of 7. We'll get a decimal approximation for that. And x equals negative square root of 7. We'll get a decimal approximation for that. So square root of 7. 2.646. Negative 2.646. And those are our solutions for that particular type of problem. So if we're looking for, if it's just got x squared in it, then square roots is the method we want to use. So we go from factoring as an option to using square roots as an option here. So it's kind of tying all this, stuff we've done back together. Let's look at this one. Maybe it's x squared plus 4 equals 0. This is always a little bit of a confusing one. The reason I do it and every time I teach quadratics is this. I do an example like this one. We almost think that that would factor as a difference of squares, but the problem is that it's a plus 4, not a minus 4 there. X squared plus 4 doesn't factor. So we've got, again, the clue you're looking for here is that you've got x squared is the only variable part in the problem. If that's the only variable part in the problem, get it by itself and use a square root. That's the best method you can have. So I would subtract 4 from both sides. And now I got x squared is equal to a negative number. Well, that really doesn't matter. I know how to take square roots and negatives. We talked about that on Tuesday, or I have an idea of what to do. So I'm going to take the square root of both sides. I'm still going to do the plus or minus in the front because I'm taking a square root. That doesn't change the fact that a plus or minus goes in the front. Okay. What's the square root of 4? It's 2. But because it was a negative 4, what else comes out? I. Remember the square root of a negative? That's where the I comes from. So the I comes out with the 2. So our answers here are x equals 2i and x equals negative 2i. Those are our two solutions to this. Okay. All right. Not too far from where we were. Say we had negative 3x squared is equal to 24. All right. So this one, not really, it doesn't have just plain x squared. It's got the negative 3 in the front of it. But the only variable part is the x squared. So I'm taking that clue and I'm saying, okay, that's the only variable part. I'm going to get x squared by itself and do square roots to solve it. That's what you want to think about here. So I'm going to divide both sides by negative 3 to get rid of it. And there's x squared by itself. But on the other side, 24 divided by negative 3 is negative 8. So, it's still a negative number over there, like example I was. So, it doesn't matter. I know how to do that. I've got x squared here by itself. So, that means I take the square root of both sides. Anytime x squared is by itself, and there's no other variable part, you can take the square root of both sides. Don't forget the plus or minus. And then we need to break that down, the square root of negative 8. We know 8 is 4 times 2. We got a pair of 2's and a 2 left over. But because it was a negative 8, what else comes outside? The I. And then there's that 2. That 2 right there is the one left on the inside. So we have plus or minus 2i radical 2. So one answer is positive 2i radical 2. The other answer is negative 2i radical 2. We don't get decimal approximations on the complex answers. Reason being is when we do the graphs, things that have complex solutions or imaginary numbers like the I, they don't cross the x-axis. We'll talk about that in a minute or in just a little while about graphs. So, we don't have to get a decimal approximation if it has an I involved. So, not too bad. All right. Well, sometimes they're not in, standard form. They're not, look kind of weird, but you still use square roots to solve, and that would be one similar to this. Maybe you got x minus 5 in parentheses squared, and that's equal to maybe something like 16. Nice, good number there. These are easily done with square roots because you look at the problem, you've got something in parentheses here all squared. I can get rid of that squared by doing the inverse of that, which would be a square root. If I take the square root of both sides, on the side with the plain number, I'm going to put plus or minus. On the left-hand side, this square root and that squared cancel each other out. That's what happens, leaving you with just x minus 5. The part that usually catches people is the plus or minus on the other side, because the square root of 16 is positive and negative 4. That's usually where folks get messed up, is they forget to put the positive and the negative. So you end up with two equations. X minus 5 equals positive 4, and x minus 5 equals negative 4. Okay, so x minus 5 equals positive 4, x minus 5 equals negative 4. And you just got to solve each one of those to get our two answers. X equals 9, and x equals 1. And we get two answers from that. Okay. Sometimes they'll throw one in like this. It's almost the same as example K, but there's that plus 3 hanging out on the outside. Again, the clue you're looking at here is the fact that you've got something in parentheses squared. That tells you, hey, you could do square roots to solve this. Okay? So to do that, you need to get all the plain numbers together. So that 3 that's hanging out on the outside there needs to go away. So we're going to subtract it. 15 minus 3 be 12. So we get x plus 4 all squared is equal to 12. I want to get rid of the squared. So to get rid of a squared, you take the square root. They cancel each other out. And there it leaves you x plus 4 is equal to positive, negative, plus or minus the square root of 12. I need to break down that square root of 12 if possible. Over here, we broke down square root of 16. It was 4. 12 is not a good number. It doesn't work out real nice. But we can break it down a little bit using our factor tree stuff that we talked about on Tuesday. So that'd be 6 and 2, 3 and 2. So there's a pair of 2's. So that ends up being x plus 4 equals plus or minus 2 square root of 3. Not the prettiest answer in the world, but definitely unique. You're going to set up two equations. X plus 4 equals positive 2 square root of 3. X plus 4 equals negative 2 square root of 3. Get x by itself. Now, I know that 4 and 2 radical 3 or 2 square root of 3 are not like terms, but that doesn't mean I can't get x by itself. So if I'm going to subtract 4 from both sides, this is what our answer is going to look like. It's going to look like negative 4 plus 2 square root of 3. And then this one would be negative 4 minus 2 square root of 3. There's not an I in that, so that means I need to get a decimal equivalent to that. So I want to break, I want to just use my calculator to get a decimal approximation for each of those. And I use the squiggly equal sign to mean approximation. We're going to round it to 3 decimal places. So I'm just going to go negative 4 plus 2 square root 3. Negative 0.536. And so there's the decimal approximation that goes with negative 4 plus 2 square root of 3. And let's do the minus. So negative 4 minus 2 square root of 3. Negative 7.464. And again, on your exam, you're probably going to see the answer more written in this form with the square root in it. The decimal approximation is going to be helpful when we start doing the graphing stuff. That's where it's more helpful out of that. Okay, so just taking square roots to solve. When you're doing that, you need to look for things that are just squared, like plain x squared, or you've got parentheses with a squared on the outside. That's when you know you need to do square roots. Other time, when you've got x squared and a plain x, that's when factoring comes in, or the next method we're about to talk about, which it works really nicely. And that's called the quadratic formula. The quadratic formula is a method for solving quadratics in standard form that, I'll say this very, very animately, always works. Very important that we realize quadratic formula is always going to work. Factoring, we've already seen cases where factoring doesn't work. Square roots is nice, but it's not all. Every problem is not going to be set up to where you could do it with square roots. If it's in standard form and you've got a plain x, then doing it with square roots is not the easiest thing in the world to do. It can be done, but it takes a lot of work at the beginning before you can even think about square roots. So I don't ever recommend doing it that way. Quadratic formula, if it's written in standard form, even if there's missing pieces, it always works. And quadratic formula is this. It's x equals negative b plus or minus. Then we get a big square root symbol. So it involves a square root. Inside of the square root symbol is b squared minus 4 times a times c. And then all of that's on the top of a fraction, and it's 2a in the bottom. 2 times a in the bottom. Okay. When I teach this in my high school classes, I always make them sing it, and I sing it to the tune of "Row, row, row your boat," and they memorize it. You don't have to memorize it. I mean, you'll have the formula and stuff on your quiz and test, but it really works well to the tune of "Row, row, row your boat." If you wanted to, it's like x equals negative b plus or minus radical b squared minus 4ac divided by 2a, and they think it's cheesy, and it is, but it helps them memorize it, and they know what parts are. Okay, so quadratic formula. The a, b, and the c are the numbers in front of x squared, plain x, and then the plain number. It's still got to be equal to 0, just like when we were factoring. So we don't have to learn anything new about order and all that stuff to do quadratic formula. Its setup is exactly the same as factoring. The difference is that we're just plugging in numbers. We don't have to deal with the x's and the factoring and find out what numbers multiply to be this and add to be that. So quadratic formula is really, really a strong tool. It's kind of like the claw hammer of algebra. that you can use a claw hammer to do a lot of things. It can drive a nail. That's its original purpose. It can pull a nail. That's its original purpose. But if I need to get into a window that's locked, it can break through the window. So it can do some work that maybe it wasn't intended to do, but it does a lot of extra work. A hammer can do a lot of things. Quadratic formula works on a lot of different kinds of problems, and we're going to see that as we start practicing with it here. Inside of that quadratic formula, there's this part right here is a big deal, okay? Because when we're doing square roots, that's where we know whether we've got an or complex solution with imaginary numbers with the I, and whether or not we're going to have, a perfect square number like a 16 or a 4 or a 9 or something in there. Depending on what that b squared minus 4ac is, tells us a lot of stuff. So that's the b squared minus 4ac. I usually do it separate because it's the most work of all that problem. The b squared minus 4ac is the busiest part. Everything else is pretty straight. Okay, b squared minus 4ac, it has a name. It's called a discriminant, is what that's called. The discriminant. And if you're a discriminant, that means you discriminate. All right? Discriminant discriminates what kind of answers you're going to have. And so this is what it tells us. If the value of b squared minus 4ac is greater than 0, that means it's what kind of number? If a number is bigger than 0, what kind of number is it? It's positive, yeah. That basic of an answer, it's positive. It means it's a positive answer. If b squared minus 4ac is a positive number, then we take the square root of a positive number. Everything's normal, right? So that means we have two real solutions, and we'll find those. We'll find the two answers just like we did on the previous examples. Every one of them we've done so far has had two answers. Okay, if b squared minus 4ac is equal to 0. Let's put a little extra space here. If b squared minus 4ac, the stuff inside of the square root, is not greater than 0 but equal to 0, means it is the number 0. That means we have one real solution. Remember at the beginning I said the degree was 2 and you would have two answers. That's the case where you have the same answer twice. It's repeated is what that's called. But it's one real number that we get as an answer. If we get the b squared minus 4ac is equal to 0. Last case, b squared minus 4ac is less than 0. Means it's a negative number. That means we're going to have two complex solutions, meaning it's got the I in it. Okay, well, the I is going to be part of the answer here with the complex solutions. All right, we'll see that as we go through solving these things. And when I'm doing this, I like to do the discriminant first and then get everything else after that. Okay, because it just shortens up the how big the quadratic formula is. Also tells me what I'm looking for later on. All right. So let's look at a few examples of solving with quadratic formula. We'll talk about the discriminant as we go there, and then we'll get into some applications of it. So I have no idea what letter I'm on because I've changed my letters from what I did. Okay. L M. Example M. All right. So let's say we had x squared minus 4x plus 2 is equal to 0. Okay. So here we have a quadratic equation. It's in standard form. It's in descending order. It's equal to 0. Everything is wonderful about it. It's ready to go. And my first instinct is to factor it. And if I try to do factoring, there's nothing that multiplies to be 2 that adds to be 4. That does not work. Okay? So that's why the quadratic formula even exists, is because there's quadratics that won't factor. So we've got to have some other way to solve them. That's why a quadratic formula exists. Factoring doesn't work on this problem. I always try to default to factoring because I'm good at it. I've been doing it longer. So that's why I try it first on all of them. You don't even have to try it first. If it just says solve and it doesn't tell you you have to factor it, you can use quadratic formula straight from the beginning. Okay. So when you're doing quadratic formula, you need to tell me what A, B, and C are so that we can plug them in to the problem. So what's A? 1. B, -4, and C, +2. Okay, so A, B, and C. And, whether you write that list or not, it's up to you. I usually write it there when I'm first starting it, just so I know to go back and I know where I'm getting things, okay? So the first thing that I want to do when I'm doing the quadratic formula, I'm just writing the formula here, is I want to go over here and do b squared minus 4ac. I want to figure out what's going on for the problem. So I'm going to take b, -4, put it in there for b, and then 4 times 1 times 2. And I'm going to work that out and see what that number is. Okay? So that'd be 16 minus 8 is +8. That's the discriminant. That being +8 tells us that there are 2 real solutions to this problem. Okay? So that means we're going to get 2 answers for this problem. Okay? So I'm going to take that and I'm going to put it into the quadratic formula. I've got -b is the first part. So -4 turns into +4. Okay? So -b just means change the sign of b and put it there. So b was -4. -b means +4. The opposite of that. Okay? Plus or minus. And here's the great thing. I've already done the discriminant, so I've shortened up this to where it's just square root of 8 right there. On the bottom, 2 times 1. Very important that you don't forget 4 plus or minus square root of 8 is all in the top of the fraction. Okay? The next thing to do is simplify as much as you can. Okay? Well, I've got a square root up here, so I need to simplify that square root. 8 doesn't have a nice square root. If it was 16, that'd be nice. It'd be 4. But it's 8, so we got to break down 8. So I'm just going to break it down with the factor tree over here under the discriminant where I did that. It's 4 times 2, 2 and 2. It's a pair of 2's with a 2 left over. That's 4 plus or minus 2 square root of 2. And then on the bottom, 2 times 1 is just 2. Now, here's what I look for when I'm trying to simplify. This number, and this number. I look at those and say, are those divisible by the same number? Yeah, every one of those are divisible by 2. Notice I did not highlight the number under the square root. It doesn't matter. Okay? You cannot divide into the number that's inside of the square root. Okay? Only the numbers on the outside can be done that way. Okay? So only the numbers on the outside. So 4, 2, and 2 are all divisible by 2. So I'm going to divide them all by 2. It's going to give me 2 plus or minus 1 square root of 2. And then on the bottom, 2 divided by 2 is 1. So I don't even have to write over 1 because that doesn't help us any. Okay? So I've got two answers. I've got x equals 2 plus the square root of 2. I've got x equals 2 minus the square root of 2. I'm going to get the decimal approximation for each of those. 2 plus square root of 2, 3.414. 2 minus the square root of 2, 0.586. And we've solved one using the quadratic formula. We're going to do a few more there of that, and then we'll see it kind of coming up as we go through some other stuff too. It's going to be, yeah. All right, let's do another one. This one should be a little bit better because we're more used to the formula now. So x squared minus 3x plus 5 is equal to 15. All right, so what's the first thing we should do from there? Subtract 15 to get it equal to 0. That's exactly right. So x squared minus 3x. 5 minus 15 would be minus 10. All right, and then take that and do quadratic formula with it. That's what we want to do. That's what we're after here. Okay. If I were trying to do factoring, there's nothing that multiplies to be negative 10 and adds to be negative 3 any. Well, actually there are, but yeah. But we're doing quadratic formula. So that's what I want to do here. That's what I want to practice for. Okay. So A, B, and C. So that'd be 1, negative 3, negative 10. Using that. So from there, do your discriminant, b squared minus 4ac. So it'd be negative 3 squared minus 4 times 1 times negative 10. And you can do that with the calculator. That's absolutely perfectly legal. Minus 4 times a times c. And just typing it in exactly like that. Be sure to use parentheses on the b squared. If you don't use parentheses on the b squared, it's going to mess it up at some point. Okay. And it gets 49. Because that's a positive number, we know we're getting two real solutions, two real numbers out of this. Okay. It's nice that it's the number 49 because we know that number is going underneath the square root. And 49 is a good number to have under a square root, right? Because we know the square root of 49. So when I do the quadratic formula, x equals negative b plus or minus, I'm going to have that square root of 49 right there. What goes here in the front? A positive 3, because remember, it's the opposite of whatever b is. If b is negative, then it's positive right there. Divided by 2 times a. And then we simplify as much as possible. So the square root of 49 is what? 7. We know that one. Okay. And then it's all divided by 2. Well, 3, 7, and 2 are not divisible by the same number. So we can't simplify that way. But we can split this into two problems. We could have x equals 3 plus 7 over 2, and x equals 3 minus 7 over 2, and simplify those. Because that would be 10 over 2, and 10 divided by 2 is 5. Yay. And then 3 minus 7 is negative 4. Divided by 2 would be negative 2. And we get two real answers there. We don't have to get decimal approximations because there wasn't a square root left over when we simplified that square root. Okay? So that one would have solved by factoring, but we can still solve it by quadratic formula. That's the great thing about quadratic formula, is that it works whether it factors or not. So that's one of the great things about quadratic formula, that it's always going to work whether it factors or not. I can use quadratic formula to get an answer. There are times that I need factoring. That's why we did it. But quadratic formula is always a nice option to have when you're doing that. So let's look at one more to solve with quadratic formula, and then we'll do some application problems. 2x squared minus x plus 3 is equal to negative 1. So first thing we would do would be what? Add 1, yeah. Add 1 to the like term of 3. There. There's the equal to 0. And there's our quadratic equation. Since we're practicing definitely using quadratic formula, I'm just going to go ahead and go for that. So 2, negative 1, and 4. And I'm going to find the discriminant, b squared minus 4ac. We'll find that part first. I can do that straight from the calculator. B squared minus 4 times A times C. I get a negative 31. It's a negative number. So that means that I'm going to have two complex solutions. Means I'm going to have i's in the answer. That's all that means. Okay. Right now, that's all it means. When we get to graphing, it means it also is not going to cross the x-axis, but we'll talk about that then. Okay. Now, from there, we're just going to simplify or work out our formula. X equals negative b plus or minus the square root of negative 31 over 2 times 2 this time, since a was 2. 31 happens to be a prime number. It doesn't break down any. So the only thing that comes out when I do my square root there would be the I. There's nothing else we can do. You don't get a decimal approximation when there's an I in the answers. And so there's nothing else we can do. So these are our two answers. 1 plus I radical 31 over 4 and 1 minus I radical 31 over 4. If you wanted to write it as two separate answers, that would be the only other thing that you could do to this problem. That's writing it as two separate answers. Nothing really else to go with that. Okay, so getting that discriminant first can be very, very helpful in doing that problem. Okay. All right, so we've got factoring as an option. We've got square roots as an option. we've got quadratic formula as an option. We got 3 different options for solving quadratics. Quadratic formula being the best option because it always works. So we've got some options for solving quadratics. That's going to help us as we go through these application problems. Got 3 or 4 application problems we're going to look at, and then we'll get into graphing after that. So let's look at some application problems. So next section, section 1.5 is applications with quadratics. So some short word problems is what I'm after here, and most of them are related to some geometry formulas that you should be familiar with it, and if you're not, we'll get you familiar with them. They're easy. Okay, so let's start with this one. A box with a volume in it of 1,435 cubic centimeters has a length that is twice the width and a height of 5 centimeters. Very small box. Find the width. Okay. All right. So we've got a box, and I'm going to attempt to draw a box. We have a box. All right. Something like a box. It's not really a good box, but it's a box. They tell us that the only thing we really know is that the volume is equal to 1,435 cubic centimeters. And they also tell us that the height is 5 centimeters. If you remember from geometry or whatever algebra class you might have done a problem like this in, the formula for volume is length times width times height. Okay, that's an H. Okay, length times width times height. It's volume of a box. Okay, so I'm going to write in some of the things that we know. We know that the height is 5 centimeters. The length is twice the width. So whatever the width is, the length, this side down through here, is twice that. So that means it takes the width and multiplies it by what? 2. So it's 2W is what the length is. Okay, so we've taken, now we have all of the things that we need. We have the length, the width, and the height. We already knew the number on the height. So we could take this problem and plug in the things we know into the volume formula. That we know that the volume is 1,435. The length is 2W. The width, we don't know. That's what we're looking for. But we do know that the height is 5. So we've got this problem where, we got a number on one side and then a couple of W's multiplied together on the other side and then a couple of numbers. So if I simplify the right-hand side, 2 times 5 is 10. What's W times W? W squared. And then over here, we still got 1435. Hey, what do you know? That looks like one of the problems that we just solved in section 1.4. It's a W squared. It's quadratic because it's got squared in it. There's not a plain W left in the problem. So that means that I could solve this by square roots. So if I'm going to solve it by square roots, and it may make you feel more comfortable if I rewrite it this way. I don't know that it matters. It doesn't really. But maybe that makes you feel a little bit more comfortable to write it with the W on the left side. But you've got to get W squared by itself. You could divide by 10, right? And we're dealing with a real world problem here, so there are decimals in the real world. So we're going to do 1435 divided by 10 will be 143 and a half. It's a legitimate number. Actually, a pretty easy number to measure. Something with a 0.5 is easy to measure. And then how do we solve for W here? Well, to get rid of the squared, we would take the square root, right? So I'm going to take square roots both sides. I'm going to get a decimal approximation. I'm only going to get an answer that's positive or negative. Should I get a negative answer on this problem? Why not? That's exactly right. It's a measurements here. So we throw out the negative part on the square root here and just get the square root of 143.5. Oops, I need the square root first. 143.5. 11.979. Almost 12 centimeters. And it's centimeters since we're dealing with, that was the unit of measure in there. So there's just an application problem using the volume formula for that. And so various, basic formula there, but, just taking that. All right. So there's one application problem down, 3 more to go. And I'm trying to do the examples that I'm trying to do are more like the ones that you're going to see on the exam. Trying to stay closer to those than I am, the ones where a train leaves Boston at 6:45 in the morning and, that kind of problem. And the answer is pancakes because, orange purple or something like that. Y'all have all seen that meme on social media. All right, so let's talk about this one. Let's say we got a poster. Has an area of 216 square inches. The width is 6 inches less than the length. Find the width. All right, so it's another problem where we're finding the width. And one of the things that I think helps with word problems are pictures. I drew a box on the first example. Here we have a poster. Posters are usually rectangles. So I'm going to draw myself a little rectangle here. The magic of... Oops. There's a nice rectangle on this one. Okay. We know that the area is 216 square inches. So area, what's the formula for area of a rectangle? Base times height or length times width mean the same thing. Since our problem talked about length and width, I'll call it length times width. Base times height is the same thing. All right. And it tells us that the width is 6 inches less than the length. Okay. So whatever the length is, the width is 6 inches less than that. So how could I write that for the width here? Perfect. L minus 6. Now, I noticed, it didn't ask me to find the length. It asked me to find the width. But if I can find the length, it's pretty easy to find the width. I just subtract 6 from it, okay? So I'm going to take that information and I'm going to plug it into my formula for the area and get, set it equal to the area that I know that it is. So I'm going to take length times width, L minus 6, and that should be equal to the area that they gave me, and it's 216 square inches. And then take that and we're going to solve it. So the best way to solve that would be to multiply out the left side, because you got L times that. It's a distributed property over there. So I'm going to distribute both of those. So that's L squared minus 6L equals 216. Well, this one's not quite as easy as the first example was, because we've got a term in there that's got a plain L. So that means we need to get this problem equal to what? You got to get it equal to 0 so that we can use one of the methods for solving a quadratic in standard form. And I could either use factoring or quadratic formula to do this one. I don't know a whole lot about the number 216. So that makes me shy away from factoring here, because I don't, I didn't, 216, I know it's even, but, as far as getting a number that multiplies to be 216 and adds to be -6, I'm going to be guessing at that quite a bit. So I'm just going to go ahead and do quadratic formula with A being 1, B is -6, and C is -216. I'm going to do quadratic formula for that. So, B squared minus 4AC, get that number. And definitely going to use the calculator to help me there. -6 squared is 4 times 1, -216. 900. So that means we're going to have real answers, and that, I hope we do. It's a real poster, so we got to have real answers for that. 6 plus or minus the square root of 900 divided by 2 times 1. Square root of 900. That's a big number. Usually when it's a bigger number like that, I'm going to try and see if 900 has a square root. I think it does. I'm lucky it's 30. Okay, it worked out to be that. If it didn't, that's okay. You can, do the factor tree and break it down. That works out to be 30. So we have 6 plus or minus 30 over 2. I used X. It should be L. We're finding the length here. 6 plus 30 over 2. 6 minus 30 over 2. Well, 36 divided by 2 would be 18. And then this one would be -24 divided by 2 would be -12. Which one of those do we keep? The positive one. This one. This one gets thrown away, because we can't have a -12. That's the length. We're looking for, what did they ask us to find? Find the width. That's the big deal. We didn't find the width. We found the length. The width would be length minus 6. So 18 minus 6 is 12. Positive 12 inches. There is our width that they asked us for. Okay. So we use that length that we found to get the width, which is what they actually asked for out of that. All right. So there's using quadratic formula to help us solve an application problem. Really not bad at all. Okay. All right, let's get to the most common formula in math, or theorem in math. That would be the Pythagorean theorem. The one most people have heard of, even if they've never studied much math. Remember, that's a squared plus b squared equals c squared. And it's for right triangles only. So we're dealing with a right triangle for you. You have to use this particular formula. So a piece of property has a right triangular shape. So there's a piece of property. Someone's looking at it, has a right triangle, that it's its shape. It's the corner of a property there. Capitalize that T. The longer side leg, we'll say in parentheses. Remember, right triangles have legs and the hypotenuse, so that maybe that's trying to jog some memory here of Pythagorean theorem. The longer leg is 20 yards longer than the shorter side or leg. The hypotenuse is 10 yards longer than the longer leg. Find the lengths of the sides. Huh. This looks like a fun one. So, it's a word problem. It's talking about a right triangle. I'm going to draw a right triangle. That's going to help. Remember that little box in the corner means that's where the right angle is. Also helps you know where the hypotenuse is. It's that slanted side there. Okay. So, and I didn't draw that real accurate there. Let me draw it a little bit more. So, with it, where it's obvious you've got one side that's shorter than the other. That's a little more descriptive of our problem. Okay, so we got a shorter leg, we got a longer leg, and then we got the hypotenuse here, that's the slanted side, and go from there. So, based on the information they've given me here, they said the longer side or longer leg is 20 yards longer than the shorter side. So whatever the shorter side is, we don't know what it is. We can call it X. But this longer leg over here is 20 yards longer than that. So that'd be X plus 20. And then here's the toughest part of this problem, I think, is that it says the hypotenuse is 10 yards longer than the longer leg. So 10 yards longer than this one would end up being X plus what? Because it didn't reference it to the shorter leg, it referenced it to the longer leg. So 10 yards longer than X plus 20 would be X plus 30. And that's the part that could get you on that one. And remember, with right triangles, the hypotenuse should be the longest side anyway, with the right triangles going from there. Okay. So, Pythagorean theorem, a squared plus b squared equals c squared. That c is the hypotenuse always. Okay. So if you're dealing with this, we're going to say it's x squared plus x plus 20 squared equals x plus 30 squared. Okay. So a lot of algebra in this problem. Some geometry, but a lot of algebra. Hey, and when you're dealing with this problem, we're going back to that multiplying polynomials and adding, subtracting polynomials that we had done last week. So this is a really good problem to review everything we've done so far, honestly. So that's why I picked it. Let's multiply out x plus 20 squared. Remember, that's x plus 20 times x plus 20. And then, the x squared, there's nothing to do to it. But then x plus 30 squared is x plus 30 times x plus 30. Remember, that's what those mean. All right. And order of operations tells us we have to do that multiplication before we can add and subtract. So we're going to multiply these together. So this one, I'm multiplying x times x is x squared plus 20x, and then multiply 20 times that, so it'll be 20x plus 400. And on the right-hand side, x times x is x squared, x times 30, 30x, and then 30 times both of those would be 30x plus, I can give myself enough room there. 900 is 30 times 30. So I'm just multiplying out those two binomials on each side there. And then I'm going to simplify and put all my like terms together on each side. So on the left-hand side, I got x squared and x squared. That's 2x squared. 20x and 20x is 40x. And then plus 400. 20 times 20. Because when you multiply, like when you take this out here, and you do x plus 20 times x plus 20, it's x times x plus 20 plus 20 times x plus 20. Remember, it's distributed property twice. So that's x squared plus 20x. And here's where the other 20x comes from. And then 20 times 20 is the 400. That's where those are coming from. Same thing on the other side with the 30, the x plus 30 times x plus 30. It's x times x plus 30 and then 30 times x plus 30. That's going to give you x squared plus 60x plus 900. 900 comes from 30 times 30. Now it's quadratic, so I need to get it equal to what? 0. Okay. This is where it starts getting a little easier because we subtract 60x, we subtract x squared, and we subtract 900. And that'll get all of these on the right side canceled out. And that's equal to 0. 2x squared minus x squared is x squared. Negative 20x, and then negative 500. Okay. And then I need to solve that. I could try factoring. I don't, a 500 is a big number. So I'm thinking maybe factoring is not the best of methods here because 500 is a big number and I got to find, that means that the bigger that number is, down here, that means the more options there are for factoring, which means I could end up studying on that quite a while and it still not work. So that's where the quadratic formula is going to come in. So I'm going to do b squared minus 4ac for this one. So that'd be negative 20 squared minus 4 times 1 times negative 500. And get it and do quadratic formula with that. That's coming from A, B, and C of this one. So parentheses negative 20 squared 4 times A times C. That's negative 500. I get a nice positive answer of 2,400. It means I'm going to have two real solutions out of that. So in the quadratic formula, that'd be x equals 20 plus or minus the square root of 2,400 divided by 2 times 1. Well, not much I can do there. The 2,400, I could break that down if I wanted to, using the factor tree. I'm not going to because it doesn't work out nice. 2,400's not got a nice square root. It's a decimal that's going to be. So I'm just going to work from here and go, okay, well, it's x equals 20 plus the square root of 2,400 divided by 2. And then the other one would be x equals 20 minus the square root of 2,400 divided by 2. I know the square root of 2,400 should be a bigger number than 20, I think. Because I know the square root of, so that right there is 48.989, which would round to 48.990. Tells me that that's going to be a negative answer. So I'm only going to have this positive one here. X is 20 plus 48.990. And that's going to be the decimal approximation here, and that's what we want. That's the real world problem. 20 plus 48.990. And then get that answer and divide it by 2. 34.495. That's in yards. That's the shortest leg, because that's what x is. Remember when we drew our picture, x was the shortest leg. So 34.495 is the first leg. The longer leg was 20 yards longer than that, so that'd be 54.495. And then the hypotenuse was 10 yards longer than that, so that'd be 64.495. And that gets us all three sides that they ask for. So not a huge piece of land, but maybe we're fencing it in or something is what we're after there. I'm not sure what they're doing there with it. But not likely that we have a tape measure that measures those. 64 yards is quite a ways. All right. So there's an application of Pythagorean theorem. You're not going to see that a ton, but definitely wanted to show that, showing up because I've seen it, come up on the final where you had to know Pythagorean theorem. Maybe it's not as difficult as that problem is. Maybe they give you a little bit more information about the the hypotenuse is actually a number. But that it won't get any more difficult than that for sure. Okay. Let's look at one more application problem. We'll take a short break after this problem and come back and do the graphing parts and then the inequalities part at the end. And so we'll take a short break after this problem. Example D. These problems are maybe some of my favorite ones for applications. Find two consecutive integers whose product is 110. Okay. So two consecutive integers whose product is 110. So that means product means what? Multiply. So it means find two numbers that multiply together that are in sequence with one another to be a positive 110. Okay. So with that, we get the stipulation. Since it says integers, what do we know about those numbers? They could be whole numbers, like positive. Maybe it's 11 and 10. Two positive numbers, but it could be two negative numbers because it says integers. So we could have two positive numbers that are right in a row, or we could have two negative numbers that are right in a row. So when we do our work here, we got to set it up to take care of both of those cases. So consecutive integers, always the first one we'll call x. The next one to be right next to that, we'll call it x plus 1. Okay. Our problem says that if you multiply those two together, you get 110. So our setup is this: x times x plus 1 equals 110. Okay. If it's consecutive integers, that's how your setup's going to be. It's going to be x times x plus 1. If it said consecutive even integers, it'd be x and then x plus 2 for the next even one. Odd ones would be the exact same way, x and x plus 2. Because remember, even numbers are 2 apart. Odd numbers are still 2 apart too. Like to get from 3 to the next odd number of 5, it'd take 3 plus 2. So if it's consecutive integers, it's going to be x and x plus 1. If it's consecutive odd or consecutive even integers, it's going to be x and x plus 2 as your setup on the left side. And then the product is always, just a number on the other side. And then we got a problem here that's pretty similar to the area problem that we did with the poster. We just need to multiply this side out and get x squared plus x is equal to 110. And then subtract 110 to get it equal to 0. And solve that quadratic. So I'm going to use quadratic formula again because I know it's going to work, and I don't have to do a whole lot of guessing on that. So b squared minus 4ac, get that number, be 1 squared minus 4 times 1 times a negative 110. 1 squared minus 4 times 1 times negative 110. 441. X equals a negative b plus or minus square root of 441. 2 times 1. I don't know a whole lot about 441, but it's under a square root. So usually before I start doing the factor tree for a number, especially when it's a larger number, like anything over 100, I try with my calculator to get the square root, see if it is a perfect square number. I don't have them all memorized, so I don't know for sure. I think it may be, though. It is. It's 21 squared is 441. So that works out nice because that then gives us a nice number there for us to work with. So we get x equals -1 plus 21 over 2, and x equals -1 minus 21 over 2. I'm not throwing either of these out because I'm talking about consecutive integers. I'm not talking about a poster board or a piece of land or any kind of real world situation. I'm talking about integers, positive and negative numbers. So it's okay to have a negative answer in this one. So one of the numbers would be 20 divided by 2, which is x equals 10. And this one would be -22 over 2, which is x equals -11. So our consecutive integers, if 10 is the first one, the next one would be 11. (10) and 11, or if I did -11, the other one would be -10. Get two sets of answers on this one because it asked for consecutive integers. If it had said consecutive positive integers, then it's the 10 and 11. If it had said consecutive negative integers, the answers would be -11 and -10. But this one just asks for consecutive integers, so you get both sets there. So we get two pairs of answers: +10, +11, -11, -10 for that. And they both multiply to be 110. So this is using an equation to set that up. I've had students in the past when I do these problems, they can, they'll make like an educated guess and then still be able to get it right. I think the equation is much quicker than educated guessing. In because I guess because that's how I'm used to doing them. But definitely something that you could do without the equation, but the equation sure makes it quicker and easier to do out of that. All right. Let's take a short break, about 10 minutes here. Go to the restroom, get you something to drink, a little snack or something, and then we'll come back and finish up for today with some graphing stuff